This video will introduce you to the fetal doppler, its basic principles and repairs for the device. This video is produced as an educational project and is not intended to provide expert information. Always consult the manufacturer's information and qualified professionals before attempting to service your biomedical equipment. Always follow safety warnings. A fetal doppler is an ultrasound device that uses sound waves to monitor fetal heartbeat. There are two types of fetal dopplers, a handheld version and a continuous belt monitor. Both versions measure fetal heart rate non-invasively. Today we'll be focusing on the handheld version. The handheld fetal doppler is used at regular prenatal checkups or at home, especially for high-risk or nervous pregnant people.
The belt version is fastened to the abdomen to get continuous measurements of fetal heart rate, specifically during labor and delivery. It is used in conjunction with a strain gauge, a togodynamometer, on another belt placed higher on the abdomen to measure strain in the abdomen from contractions.
Both types of fetal dopplers are used to track fetal heart rate to ensure that the fetus is safe during the pregnancy and birth. Drastic variations in heart rate can indicate issues with fetal heart development or distress of the fetus. Normal fetal heart rate is typically between 110 and 160 beats per minute and can vary throughout pregnancy up to 25 beats per minute as the fetus adjusts to changing conditions in the uterus. For example, if the fetus has a temporary lack of oxygen, heart rate may increase significantly in an attempt to supply the fetal body with a limited supply of oxygen. If the fetus experiences a prolonged lack of oxygen, the heartbeat may begin to slow from the lack of supply. If a situation like either of these or similar distress occurs, there may be a need for a medical intervention or a cesarean or C-section. Ultrasound is the use of high-frequency sound waves to extract information regarding tissue properties along the path traveled by the sound wave. An ultrasound device has in its probe a piezoelectric transducer, consisting of a special type of crystal which converts movement to electricity and vice versa. The device sends an electrical signal to the piezoelectric transducer, which then produces a specific frequency sound wave. Fetal heart monitors tend to use sound wave frequencies between 2 to 3 MHz. This sound wave is emitted from the transducer and travels through the skin to the fetus. To make sure the sound wave can get to the skin, a gel is used to fill any minute air pockets between the ultrasound probe and the skin. The gel is important because it ensures the sound wave gets to and through the skin without significant reflection at the boundary between the probe and the skin. The sound wave propagates along its beam path through the tissue and is reflected back towards the transducer by various tissues, like an echo. The time it takes for the sound wave to travel back to the transducer is directly related to the depth of each tissue. This time delay is recorded by the machine and indicates how far the sound has traveled. Additionally, different tissues reflect the sound at varying intensities, which is how the machine can tell what tissue type is reflecting the sound wave. The machine emits a steady ultrasound signal, so as the fetal heart contracts or fills, and the surface of the heart moves closer or farther from the probe, the movement is picked up by the machine. Changes in the time delay that it takes for the echo to get back to the transducer are recorded. When sound waves reflect off something that is moving, the frequency of the reflected wave also changes. This is known as the Doppler effect. The fetal heart monitor then uses those changes to determine the oscillating activity of the fetal heart. This is updated in real time as data is acquired to track the fetal heart rhythm. The machine then produces an audible signal that corresponds to the heartbeat and displays the beats per minute. The primary components of the device include the base unit and the probe. The base unit contains many essential controls and displays, such as the digital display area, which shows live heart rate data, volume buttons to increase or decrease the volume, power button to turn the device on and off, the speaker area, where the audible output signal is emitted, earphone jack, which allows for private listening, probe connection port, where the probe connects to the base unit, and the probe. The standard probe operates at 2 to 3 MHz frequency, allowing detection of fetal heartbeat. The consumables for this device include ultrasound gel, which enhances signal transmission between the probe and the skin, and batteries, which provide power for portable operation. As a battery-operated device, it's important to maintain a healthy battery level and regularly change out batteries to avoid failure. Fresh AA or AAA batteries should each supply a 1.5 volt potential. You can check the voltage supplied by batteries by removing them from the device and using a multimeter. You can also check the battery type from the manual for the device or by opening up the back panel of the device to view the batteries. Since this device has two primary components, it's important to ensure a good connection between the two. Some versions of the device may allow for disconnection of the probe from the base unit of the device. If there's an issue, check to make sure that these connections are maintained and crack-free and undamaged. If the cable can be replaced, this would be an easy way to repair issues localized to the connection. If there is visible damage to the cord, it may be helpful to apply electrical tape. A common source of error for these devices is the probe itself, which contains 1 to 2 piezoelectric transducers used for measuring and thus must be handled with care. Issues with the probe may be indicative of issues with the piezoelectric transducer component, which can occur from dropping or extended use of the device. If the issue is narrowed down to the piezoelectric transducer, they may need to be replaced to make the device functional again. Replacement of the transducers may outweigh the cost or the value of the device in total. Low sensitivity to motion of the fetal heart may be due to poor connectivity within the device. To investigate this, the device should be turned off and batteries should be removed for safety. The device can be opened up so that the circuit can be examined. You can begin investigating the connectivity using a multimeter and the continuity setting. Resolder the internal circuit where needed. A cord shake can also be performed to see if the connection between the probe and the base units have been disrupted. If shaking the cords while holding the probe steady provides a signal, there's likely an issue with the cords connecting the components. Resoldering should be performed where connectivity has been lost, and heat shrink should be applied to ensure insulation of the connection. Finally, gel helps increase sensitivity of the device, so experiment with adding more gel to provide the best transmission possible. This concludes our instructional video. Thank you for watching.